Hello, marine biology class. My name is Kyla Pearson, and I am an instructor here at Cabrillo. I am also a Cabrillo College alumna, and after Cabrillo, I transferred to UC San Diego, where I majored in marine biology, and then I stayed at UC San Diego for graduate school, where I researched the deep sea, and I studied my favorite thing ever, deep sea worms. So I am so honored to be here today with all of you to talk about the deep sea. I'm obsessed with the ocean, always have been, always will. So that said, without further ado, let's delve. Also, since I have introduced myself, I am going to be closing this little window. All right, here we are, the deep sea. So first I'll give a definition of the deep sea. Then I will talk about deep sea zonation. And then I'll talk about the history of deep sea exploration, followed by how we research the deep sea. So what types of materials and tools we use to get down into the deepest parts of the ocean and study it. Then I'll talk about deep sea adaptations, followed by deep sea fauna. And then lastly, I'll talk about my favorite thing ever, deep sea worms. So first off, what is the deep sea? What makes the deep sea the deep sea? The deep sea is defined as the space in the ocean where sunlight begins to fade / cannot penetrate to. So naturally, the deep sea is very dark. Generally, the depth of about 200 meters or 655 feet is used to describe where the deep sea begins. However, this depth can change based on clearness of the water and a photon's ability to shine through the depths. So what do I mean by this? At the poles, where the water is very cold, and knowing what you know about phytoplankton, would you expect a photon to be able to penetrate deeper or shallower than 200 meters? Think about it for a second. Phytoplankton like cold water. Phytoplankton would also block a photon's path. So, shallower, more phytoplankton to obstruct the photon's path. A photon is a massless particle of light. Okay, furthermore, at the equator, where the water is very warm, would you expect a photon to be able to penetrate deeper or shallower than that average of 200 meters? Think about it for a second. Deeper, clear water that a photon can travel through easily. So warm water, there's less phytoplankton, less particulate in the water, which makes a photon able to travel deeper. Okay. So knowing what you now know about phytoplankton, particulate, and turbidity in the water, would it get darker faster in the water on the left or the water on the right? Yes, the water on the left. So the point of this concept is that deep sea begins below the photic zone where photosynthesis can happen. And the start of the deep sea has somewhat of a blurred line, but generally it's about 200 meters. Okay, so now we will talk about zones of the deep sea. So first up, we have the epipelagic. Epi means on top of. So this is kind of like the epidermis. The epidermis is the top layer of your skin, just like the epipelagic is the top layer of the ocean. This is known as the sunlight zone. Photons are able to penetrate water, photosynthesis, primary production, phytoplankton. Most fauna or animals, most animals that we know and study live in this zone. And then we have the mesopelagic. This is known as the twilight zone because very little sunlight makes it to this depth. So when you walk out at the end of the day and it's twilight, it means that there's a little bit of photons swirling around in the air that allows you to see, but not very many. Same as the mesopelagic twilight zone. So this is where deep sea adaptations by fauna begin, and this is where photosynthesis halts. Next up, we have the bathypelagic zone. This is known as the midnight zone. Almost no sunlight reaches this depth, so almost no photons are able to penetrate to the bathypelagic. Sperm whales and elephant seals are able to dive to this midnight zone to forage on deep sea squid. So these are two marine mammals, sperm whales and elephant seals, and those are some pretty cool deep sea adaptations because they're able to dive down to incredible depths of water to forage for food. And I'll get into deep sea adaptations later, but I just talked about that. Okay, now for the abyssopelagic. This is known as the abyss, and it's pitch black, no photons whatsoever. By this depth, the temperature is near freezing, and the pressure is between 200 to 600 atmospheres. Next up, we have the hadopelagic. This is characterized by deep sea trenches, hydrothermal vents, methane seeps, chemosynthesis, which I will get into in my next slides. The pressure can exceed 1,100 atmospheres, which is incredible. It's a heck of a lot of pressure. Okay, so you and I right now can feel 1 ATM on us all the time, 1 atmosphere. That is how much pressure we are feeling 24/7, 15 pounds per square inch. So we don't really feel this 15 pounds of square inch because evolution is so cool. Evolution is amazing. And we have evolved to be able to deal with this 15 pounds of square inch on us constantly. Just like the hadopelagic animals living in the bottom parts of the ocean have evolved to deal with 15 psi times 1,100 ATMs is 16,500 psi. So everybody stick out your hand so that the palm of your hand is facing up. Now visualize about a square inch on that palm. Now visualize 2 adult male African elephants standing on that square inch of your palm. So what would happen is your hand would break and those elephants would fall right through. So we have not evolved to be able to deal with that pressure. However, deep sea fauna are exhibiting that pressure constantly. Pretty amazing. I'll get into how these deep sea animals are able to deal with that pressure later. But for now, let's keep going. Okay, so the deepest part of the ocean is called the Challenger Deep, which is 6.8 miles down, just shallower than 7 miles down. And the Challenger Deep is at the bottom part, this most southern part of the Mariana Trench, which is off of Japan, the Philippines, Taiwan, New Guinea, and right off of Guam. So this is the deepest part of the ocean. And then within the Mariana Trench, the deepest part is the Challenger Deep.